We're now going to provide some definitions about functions and their intervals and how they behave as they move from left to right. And so we're going to start with the idea of having an interval from a to b of a function. And this interval from a to b are where things change, where it changes from going up to going down to going constant and so on and so forth. And we're going to select 2 points from these, x1 and x2, so that they are members of, elements of this interval, a to b. So remember, this means that x1 is found in here and x2 is also found in here. And if that's true, then we can talk about this interval and whether it's increasing or decreasing. So let's start with increasing. If x1 is less than x2 and f of x1 is less than f of x2, then it's said to be increasing. In other words, as it moves to the right, it goes up. So a straight line does this, where every point is higher than the one before it, because its output to the right is bigger than the left, as its input is bigger than its output. It could also be a curved line, so that every point on the line is higher than the one before. Decreasing is similar. If x1 is less than x2, so we're going from left to right, and f of x1 is bigger than f of x2, then it's decreasing. It goes down as it goes from left to right. This is like our negative slope. A negative slope is a decreasing line. So our line is going down, or our curve is going down in some way. Those are all decreasing lines. Constants are similar. If x1 is less than x2, meaning we're going from left to right, and f of x1 equals f of x2, then it's said to be constant from left to right. It doesn't go anywhere. So there's no up or down arrow here. It's just going across. So the only type of line we have for that is a perfectly horizontal line from left to right. It's staying the same. So that's how we determine if something is increasing, decreasing, or constant. And we use that information to help us keep track of the function. We have a few more definitions we want to talk about. Relative minimums and maximums. A relative minimum, we may have a graph that looks something like this. In fact, I'm going to use the same graph for both minimums and maximums. But for some interval, from a to b, let's say, this point here, let's call it c, f of c is less than f of a, and f of c is less than f of b for all a and b, then c is said to be a relative minimum. So it's a low point in a small range of the graph. A relative maximum, on the other hand, would be this point d, which is between e and a. And so a relative maximum then is a high point within some interval from a to b. Now, 2 more definitions, and then we're going to give our last one. When we talk about even versus odd functions, an even function is defined as whenever f of minus x equals f of x for all x. In other words, an even function is symmetric about the y-axis. If you fold it on the y-axis, you get the same graph on both sides. An odd function, on the other hand, is when minus f of x equals f of x. Oh, no, did that backwards. When f of minus x, there we go, equals minus f of x. When we plug in a sign change on the input, it's the same thing as a sign change on the output for all x. In other words, this is symmetric about the origin. And if we keep track of this, and we're going to talk about this later, then this allows us to know something about the graph and helps make graphing it a little bit easier. The last thing we're going to talk about is the average rate of change. And the average rate of change is defined as the slope between 2 points on a graph. And if you remember our function notation, it's actually going to look very similar. The average rate of change is defined as f of b minus f of a over b minus a, which another way of saying this is that this is a y2 minus a y1 over an x2 minus an x1. But the thing to remember here is that this value works for any type of line, not just linear equations.